This is the second of 2 videos covering IPv6. IPv4 addresses will be around for a while, and several mechanisms are in place to help with the transition. One of these methods is running a dual stack. We will show you how to configure IPv6 global and link local addresses using UEI-64 as well as auto configuration. We will cover duplicate address detection, or DAD, and we will go over several of the commands to configure and verify IPv6 configurations on the router. In order to get the full benefit for this video, you will need to download and install the most current version of Cisco's Packet Tracer or an equivalent network simulator. If you do not already have a network simulator, please pause this video and download it now. IPv6 utilizes several strategies for the migration from IPv4. One of these strategies is a dual stack network. A dual stack network is a network where all the nodes have both IPv4 and IPv6 enabled. IPv4 is enabled by default. However, IPv6 must be manually enabled. You must enable and assign IPv6 addresses to your interface like this. Please pause the video and run these commands in your network simulator. The command IPv6 Unicast routing globally enables IPv6 and must be the first IPv6 command entered on the router. You can configure an interface without the IPv6 Unicast routing command, but the router will act like a host and will not route the IPv6 packets. You can utilize a DHCP-v6 server, either stateful or stateless, to provide IPv6 addresses, default router addresses, and DNS server addresses. You can also manually configure an IPv6 address by defining the entire 128-bit address or just the network and prefix address. Alternately, you can use the built-in mechanism called Stateless Address Auto-Configuration, or SLAAC method. SLAAC hosts use Network Discovery Protocol, or NDP, messages to learn the first part of an address, plus the prefix. The router can automatically generate a unique interface ID called the UEI-64. To compute the UEI-64 address, first split the 6-byte MAC address into 2 halves. You can see the MAC address by performing the Show Interface command on a router and look for the burned-in address, or BIA. As you can see, our BIA for the Gigabit Ethernet 00 interface for router 1 is BIA 00D0975D001. To exit from the Show Interface prompt, press any letter key on your keyboard. Now, let's split our BIA into two equal parts, the OUI and the manufacturer unique ID. Next, insert FFFE in between the two halves. Next, write the next two hex digits as binary, then invert the 7th bit. All zeros becomes all zeros 0010. Now convert the binary back to hex and we get. This changes the value to the following for the host part of the address. Here are a few more examples of IPv6 UEI64 to practice on. The answers will be provided at the end of the video. SLAAC provides the ability to address a host based on the network prefix that is advertised from a local network router via router advertisement, or RA. RA messages are sent by routers by default every 200 seconds. These messages include information such as one or more IPv6 prefixes and default router addresses. The first video covered unique local addresses, or ULA, and how it is used as a site address or within an organization. We also covered the global Unicast address, which acts like a public IPv4 address. Now we will cover the link local address. Each IPv6 interface on a router or host uses a second IPv6 address called a link local address. The link local address is auto-configured and always starts with FE80 followed by 48 bits set to 0. These addresses are not routable but are used for point-to-point communications. Enter